Hello, SES students. My name is Jessie Kaylee. I work for the City of Eagan. I'm their Water Resources Specialist. And last time you saw me, I was out in the canoe on Carlson Lake. This time, I'm at the home office, and I'm going to talk to you from here about your pond projects. For this group, I'm going to be talking more specifically about Secchi depth readings, trophic states, and chloride. In Eagan, like in many urban or suburban communities, we do have challenges keeping our lakes and surface waters clean. And the main challenge is that anytime it rains or snows or melts, that water runs into some kind of surface water. So we do try to do different things at Eagan to protect our lakes and also to clean up that stormwater before it goes into the lakes. So I want to tell you just a little about that. And then I want to talk about your group's specific lake data and what it means, and give you some more resources for your project as well. So the main take-home point that I want you to come away with from this project and this talk is that land use drives water quality. That means anything that is done to the land will affect the surface water and groundwater quality nearby. So in general, the more people there are, the more buildings and roads and infrastructures you need, and you tend to have more stormwater. It tends to be dirtier. So the more pollution there is, the more of that goes into surface waters directly. You can see that, for example, in Eagan, between 1950 and 2020, there's quite an increase in how many people were living in the community. And then there's an aerial photo on the bottom showing Fitz Lake in '91 versus 2019. So you can see there was quite a bit of difference. You can imagine the kind of impact that that has on the lakes. Keep in mind that this is not just direct runoff. A lot of what we're talking about goes into the catch basins, the storm pipes, and then from within the stormwater system, it gets transferred around the city just for drainage and safety reasons. So that is a big complicating factor as well. And again, here's a diagram showing what maybe a natural state would be, where most of the water soaks in or gets evapotranspirated from the plants and the trees, versus something like a city where you have more than half of the water is now running off and it has to go somewhere, and it does tend to carry more pollution with it. So we can look at the percentage of impervious surface cover, and that gives us some idea of what kind of pollution load we're talking about. In Eagan, we can do a couple different things to help make this better. So one thing is to clean up that stormwater before it even gets to the lake. We can filter it, we can slow it down by putting constructed ponds in the way. We can soak it in with rain garden and other infiltration areas. We can clean up the impervious surfaces themselves. We can send out the street sweeper truck. We can make sure we clean up spills right away. Volunteers help with doing that for their own curbside areas, and then we can require this of developers and things like that. As far as lakes themselves, we can do alum treatments, and I'll talk about that in a minute. We can aim for a healthy balance of plants, not too many, not too few, and the same for fish. We don't want all, bullhead. We want maybe a good balance between predator and prey fish. So we do a lot of things to try and make the stormwater cleaner going in and to keep our lakes healthy. Here's just a few pictures of that. There's an iron sand filter. It's like letting the pond water soak through a sandbar with iron filings in it. So that helps clean up some of the phosphorus. There's a picture of a storm pond where this is a pretty classic urban storm pond area. It just helps to let the dirt settle out, honestly, before it goes to the next pond or lake. Here's a picture of a rain garden. This is especially good because it's collecting water directly off the street, so it will produce a better impact maybe than a backyard rain garden that's just collecting off a roof, but both kinds are helpful. And then you can see a picture of a street sweeper, a volunteer cleaning a storm drain, and then a bad situation where someone has blown other grass clippings into the street. That's what we want to avoid. Here's some pictures of a contractor's boat. We hired this company to do alum treatments. Alum is short for aluminum sulfate. You can look that up online or read more about it on our webpage, but it binds with the phosphorus in the water column and then settles down into the sediment. So it helps sort of turn off the algae growth for what's in the lake right then. Plants are important, but we do have the capability in at least 3 of our lakes to run this plant harvester that the city owns and help make more open water when the plants can get to nuisance levels. The city does some fish stocking and surveys, and then winter aeration helps keep the larger fish alive and the smaller fish, but what we want is those large predator fish to stay alive over the winter, even in low oxygen conditions, so that they can help control the small fish populations that may otherwise become stunted. So this is the part where I want to talk about your group specifically. There's all kinds of important things to know about a lake, but in your group you are going to talk about Secchi depth, trophic states, and chloride. A Secchi disk reading is also known as a Secchi depth, and it is a measure of water's clarity or transparency. It can be wildly different from one water body to another. It is correlated with, it's related to, how much algae, and therefore how much phosphorus, may be in a water body. And it's not a direct measurement, of course, but it's an easy way to get a rough idea of what's happening. And we use this a lot because there's a lot of volunteer data out there. It does give you a good sense of how much light is getting into the lake. Plants, of course, need light to survive, so if you have an extremely low Secchi disk reading, you can't see very far into the water. That means plants aren't going to be very prone to growing in that water body either, if that state persists all year. Now, it does change over the course of the year. There's a more active growing season in warmer water temperatures with more direct sunlight, so the water does tend to be clearer in the winter, in the spring, and in the fall. You might see fairly clear water right now, or there might be a late season algae bloom. It's sort of hard to tell. I think for the lakes that we would normally do sampling on, we would take at least 2 Secchi disk readings a month, just so that we don't have one single algae bloom instance that affected all of our data, if that makes sense. We need quite a few measurements to be able to rely on what this is telling us. So for you guys to take 1 reading, that's great, and you can learn how to do it. If we were going to use that data in a study, we would probably take more. But it's an easy measurement, and it's kind of fun, and you can see what color the water is, and you can sort of get a better look at some of the larger plankton and things like that. In Minnesota, you can see that there is a standard of 1 meter of clarity for shallow lakes and 1.4 meters for deeper lakes. Now it's time to talk about this concept of the trophic state. This means how rich is the food chain within a lake. That's most of the time related to the sediment type that there is in the lake, or I suppose the inputs coming into a surface water. So really hyper-eutrophic lakes and water bodies are going to be rich in nutrients. They're going to support a lot of algae growth, phytoplankton growth, and then those in turn would support the higher trophic levels above them, plankton, planktivores, small fish, large fish. So as you move from hyper-eutrophic through eutrophic, mesotrophic, and oligotrophic, you're going to have a lot more scarce of a food chain. And the way that they arrive at this trophic state index, so an index is sort of a measurement number of some kind, is that you might look at the total phosphorus. So let's say we had total phosphorus was about here, and then how much chlorophyll is there, maybe here, but how is the transparency, maybe here. So then you might arrive at a trophic state index somewhere in the middle of those 3. And there's a formula for doing that, but the important part is to understand that there's multiple variables looked at when we're trying to decide what is the trophic state. And most of the time in Egan, our lakes are going to look eutrophic on average over the summer data. But as you are measuring stuff, because it's fall, you might think that it looks more mesotrophic, and that's understandable. Just know that we would look at all of the data that we average over the summer. This is a listing out of sort of descriptions of trophic states, going from oligotrophic lake, which you might imagine as sort of northern Minnesota or some of the Great Lakes that are deeper and less nutrient rich, going down all the way to extremely hyper-eutrophic lakes at the bottom where the trophic state index, TSI, is greater than 80. So you would have things like algae, scums, summer fish kills, sort of a bad situation. So in Egan, generally, we would have sort of ones in the middle, mostly eutrophic lakes. The last thing I'll talk about today is chloride, and this is something that's important to know about and understand a little more because we are turning more attention to it these days. Road salt is applied in the winter to make roads safer to drive on, but it does have impacts for the environment. Road salt does melt ice, but only at sort of middle cold temperatures. If it's incredibly cold, it doesn't work that well. Magnesium chloride is something that can be used, but it still contains chloride. It settles down in deep water because it forms sort of a heavier layer in lakes that are deep enough to stratify. And in those cases, sometimes it just gets more and more concentrated. It can be a real big problem. It is toxic to freshwater life at certain levels. It has other effects as well. It is, of course, seasonal because not much goes in during the summer, but a lot goes in during the winter. And it depends. Mostly the solution is to just not put it in. It's really almost impossible to get it out of a system once it's in there. So testing so far doesn't look good. It shows up in levels that are too high in 1/3 of the Twin Cities wells that have been tested. The answer really, like I say, is to control salt use. It's better to sweep up the excess salt that you may apply after the snow and ice is melted. It's better to add less, and it's better to plow and shovel often so that you don't need to melt so much ice. The Minnesota chloride standards, the things that we need to stay below, are 230 milligrams per liter. Chronic means over a long time. So they define that as 3 readings in 1 year have to be below 230 milligrams. So if you have 3 instances per year that are higher than that, then they say you have a chronic impairment. If you have even 1 reading that is higher than 860 milligrams per liter, acute means short term, that's 1 time. So even that is too much. So there are plans being put into place for how to better regulate chloride. And there's been a lot of training for like plow drivers and those types of folks who might be applying the salt as part of their job, but maybe there's a way that they can do it in a more targeted way that would be better. So overall, for your pond presentations, I'm giving you some resources here, and you can pause the slide or you can look at the PDF that I'll send to your teachers for these links. And if you have any questions, I don't mind at all. You can email me and I'll do my best to answer them. Stay safe, everybody. Hang in there, and we'll see you next time.